Welcome back again. It's time to solve some systems. These are linear systems, meaning there's no exponents in sight, just everything to the power of 1. We have two equations and two unknown values. You have to have those two equations to solve for two things that you don't know. And then I'm giving you the option of picking which way you solve it. But some will have, it will be easier to solve some by substitution, some by elimination. Number 29, let's do that one first. And I'm actually going to do both on this one. And the first way I'm going to do it is with substitution. Substitution is where you plug in something for something else. Elimination is where you get rid of something to solve for the other thing. So plugging in, substitution, getting rid of something, elimination. Makes sense. All right, if you want to substitute, then you have to have an equation that says y equals this or x equals this so that you can replace that variable. So let's look at the second equation here. I'm looking at this guy. Let's be a little easier on the highlighting. Okay, if I add 5x to both sides, then this becomes y equals 5x minus 18. These aren't like terms, they're being added to each other, so I can just put them in whatever order I want, and I wanted the x's to be first. Okie dokie. So if that's what y equals, and I know that I want that to be true, then I can take that 5x minus 18, which is what y has to be equal if this is going to work, and I can plug it in for that y right there. And so what's going to happen is I'm going to look at that first equation, negative 7x plus 5. The only thing that's going to change about that equation is instead of writing x, I'm going to replace it with, and instead of writing y, I'm going to replace it with the thing that I'm saying is the same as y. That's what this equal sign means. It means those two things are the same. And so in any equation, I can either put a y, or instead of y, I could put a 5x minus 18. And so now you've got this nice equation that you have to solve. You have to distribute that 5 into the parentheses to get 25x minus 90 is equal to 0. Add these two things together, you get 18x. Let's add 90 to the other side is equal to 90. And then we divide by 18. We get x is equal to 5. Okay, that's part of the solution. It's not the whole solution. Now we have like a second substitution to do. Now, if you look at the first equation we had, y equals this. Well, now we know what x is. So we can say y equals 5, not 5x, but 5 times 5. How am I going to turn that into an 18? Yuck. Okay, 25 minus 18, y is equal to 7. So 5, 7. That's the substitution. And it's worth noting that if you graphed both of those, then the intersection point would be the 0.57. And if I just said, hey, is 5, 7 a solution to that system? Let's say that nothing else. I didn't say, hey, solve it. I said, is 5, 7 the solution to the system? Then all you'd have to do is say, okay, negative 7 times what's x? 5 plus 5 times 7. What should this equal? I'm typing in the first equation there. It should be equal to 0. Boom, it is. The second equation, negative 5x. What's x? It's 5 plus y is 7. What should that equal? Negative 18. Boom, it is. And so if both of those two things are true, when you plug in 5 and 7, then that has to be an answer. So we know that that's correct. We know that that answer is right. And we know that that's how you solve it by substitution. But how would a person go about solving that? By elimination. How do we get rid of something out of this equation? The way we do that is by adding these two equations together. Shouldn't have erased that. The answer is 5, 7. How do we get rid of something? Imagine that if you had some chips and some drinks that you put on the counter at the store, and they said that's $10, and someone else had chips and drinks as well, and they put them on there and they said, okay, that's $12. Well, what if you said, hey, let's just pay together, and they took their chips and drinks and put them on your tray as well? But then how much would it be? 10 plus 12, it would be 22. You can just add up what you did to what they did, and the prices will add as well. So it's almost like we've got chips plus some drinks equals some money. Nothing's free though. And so we can theoretically add these two equations together to create a third equation that's also true. And what we want to do is we want to add them together and eliminate something, get rid of something. But as they are, if we add them together, we don't get rid of anything because we're going to have negative 12x's and 6y's. So how do we get rid of something? We're going to have to multiply one or sometimes both equations. In this case, just one equation. I want the y's to have coefficients that match but have the opposite signs so that when they add up, they get 0. So I need a 5 in front of here, but I need to be negative. So I'm going to multiply it. And that's going to become, so I'm going to have negative 7x plus 5y equals 0. That's still the first equation. The second equation, I'm going to distribute that negative 5. It's 25x minus 5y. And then this part's very important. The multiplying has to be done to the whole equation, not just one side. And now we can add these equations together and we get 18x plus 0y's. We have gotten rid of them. We have eliminated them, is equal to 19 or 90, sorry. Divide by 18 and we get x equals 5. Hey, cool. That's what we got earlier. It's working. And now I'm going to use another equation or this equation to find out what y is. And this part's very similar to the previous part, the substitution method, because we're plugging in now, we're substituting something. Does it matter which equation we work with? No, because both of them should work if it's actually a solution to the system. So we just plug in 5 for x now because we know that that's what x should be. Get negative 25 plus y equals negative 18. Add 25 to both sides, and you get y equals 7. Nice. Okie dokie. That's the methods to both. You want to see one more? It's bonus coverage time. Let's go to number 32. If you still need a little help, we'll do number 32. If you don't, move on to the next one. Okay, again, we don't have anything that matches up, and this is actually one that's pretty easy to solve by substitution. All we have to do is add this y over to the other side. You get x equals y minus 9. So x and y minus 9 are the same thing, right? Well, here's an x, also known as y minus 9. We can plug that back in. We get negative 6y plus 54 minus 8y equals 2. That's negative 14y plus 54 equals negative 2. We can subtract 54 from both sides. So now we're in the solving phase. Negative 14y equals negative 56. And then we divide by negative 14, and that is y equals 4. That's half of our solution. So we just take that back over to this previous example or this previous equation. Plug in. 4 minus 9 is x. X is negative 5. You can write it as an ordered pair. Negative 5, comma 4. That is our solution. Bonus coverage part 2. I'm going to do 31, and I'm going to do it by elimination because this one's got something tricky to it. So number 31, if you multiply this, you can multiply this bottom equation by something to make these coefficients match up. Because right now they're not the same, so they're not going to eliminate. We want to multiply this bottom equation by something to make the numbers match but have opposite signs. And I can multiply it by negative 3. What happens? We get, this is just the first equation. Second equation is going to become, whoops, it's going to become 6x minus 3y equals 39. Now watch what crazy things happen when we add these up. Cancels, cancels, cancels. What is it? Whoa, what? So what do I have on the left side? Nothing. What do I have on the right side? Nothing. Is this true though? It is true. Also, that looks like a face maybe. It's true. If 0 is equal to 0 and it doesn't matter what x or y is, then that means that there is an infinite number of solutions. You want to know why? Because these two equations are the same line, which means if it's a solution to one, it's automatically a solution to the other one. And yeah, so there's an infinite number of pairs. Now it still has to make one of the equations true. You can't pick just any two numbers, but if you find one that works for one equation, it's going to work for the whole system. So there's an infinite number of possibilities. The other possibility that could happen, you might have a problem kind of like this, that where everything cancels except it says something like this, 0 equals 4. If it's a non-true statement, then that means there's no solutions. There's nothing x and y can do about it. You can't make those two things be equal to each other. And that happens if the two lines are perpendicular. It means they run next to each other like train tracks, but they never cross. All right. Thus ends the bonus coverage.